Welcome back. Hello, students. This is just a summary of our previous lesson. During our previous lesson, we treated chemical equilibria on acid and bases theory, and this is just a video summary of what we did in our previous lesson. So we did on acid and basis theory. There were two theories that we studied. We took off Arrhenius theory of acid and bases, and we also discussed the Brønsted Lowry theory of acid and bases. In these two theories, they just one and the same thing, but they differ in their presentations. According to Arrhenius theory of acid and gases, of acid and bases, you can understand that an acid is a substance which ionizes in water to give hydrogen ion. And a base is a substance which ionizes in water to give hydroxide ion, especially as the only OH ion. Conversely, Brønsted theory also came up with a newer theory, despite the fact that Arrhenius said all these, they ionize in water to give acid ionized in water, giving a proton, or giving hydrogen as the only hydrogen ion. And a base ionizes in water when in solution to give OH as the only OH ion. But there was some concept behind that was put forward by Brønsted Lowry, and which today becomes the Brønsted Lowry theory. That beside this, beside the fact that an acid ionizes to give an a proton, and a base ionizes to give an OH ion. This acid is a proton donor. He considered the ionization to be a proton donor, that acids are proton donors, and bases are proton acceptors. He went forward in trying to demonstrate it that acid and bases are proton acceptors. In this case, he used an example of ammonia and water to give ammonium ion and hydroxide ion. Why do we say an acid is a proton donor? An acid is a proton donor in the sense that, based on this equation, it donates a proton to a base, which is ammonia. The base, based on the second definition of the base for a Brønsted Lowry theory, the base itself is a proton acceptor. Ammonia here is accepting a proton donated by water because there is a lone pair here. So a base, in other words, is a proton, is a base, in other words, is a proton acceptor. We could also say a proton is a lone pair acceptor. A proton is a lone pair acceptor. So the water donates a proton based on Arrhenius equation or law to ammonia, which is the base. The base is the proton acceptor. In doing that, ammonium is formed and the hydroxide ion. Take into consideration that every acid has a conjugate base and every base has a conjugate acid. This is a base. And what is a conjugate? What do we understand by a conjugate? A conjugate, in terms of an acid, a conjugate acid or a conjugate base is that substance that is left after the acid must have given out the proton. If water has given out a proton to ammonia, what is left here is a hydroxide ion. And automatically we consider a hydroxide ion to be the conjugate base of water. In terms of base, we said a conjugate is something, in terms of base, is something that is formed when a base accepts a proton. This is a base, and the conjugate of this will definitely be this. This is an acid. This is the forward direction. In the forward reaction, for this reaction, ammonia plus water to give ammonium ion and hydroxide ion. In the forward reaction, the water molecule donates a proton to ammonia to form ammonium ion and hydroxide ion. So water is acting as an acid, and ammonia is acting as a base, accepting a proton. In the backward direction between ammonium and hydroxide ion, the ammonium ion donates a proton to a hydroxide ion. The ammonium ion that donates a proton to hydroxide ion is an acid, and the hydroxide ion that accepts the proton is a base. So we can now say in the forward direction, water is an acid and ammonia is a base. In the backward direction, ammonium is an acid and hydroxide ion is a base. In terms of acid-base conjugate pairs, acid-base conjugate pairs, this is ammonia, which is the base, and the conjugate is what is formed after the acceptor of a proton is this. The base is ammonia and the conjugate acid is ammonium. So because every acid has a conjugate base and every base has a conjugate acid. So the conjugate acid for ammonia is ammonium. Again, every acid has a conjugate base. For water is an acid because it's a proton donor. The conjugate base would definitely be hydroxide ion. And that is how we can get it. Secondly, we know protonation of bases can lead us to conjugate acids. Protonation of bases can lead us to conjugate acid. In other words, if you are given a base and you are asked to look for the conjugate acid, since we said a base must have a conjugate acid, and acid must have a conjugate base. If you are given a base, for example, ammonia, to look for the conjugate acid, the simple formula is you protonate it, or you add a hydrogen here on the ammonia plus a positive charge. If we add a hydrogen here and a positive charge, we will have an ammonium. That is the conjugate acid. On the other hand, if you are given a conjugate acid to look for the base, because we said every acid has a conjugate base and every base has a conjugate acid. So now, let's say this is the acid. You want to have the conjugate base. The conjugate base for this will be what? You have to take away, give out a proton. You have to give out a hydrogen and a plus charge. If we give out a hydrogen, we become, and if we add a negative charge there, it becomes, the negative charge will neutralize this one. So in order to have the corresponding conjugate base, we need to remove a hydrogen and add a negative sign. If we remove a hydrogen here, it will be ammonia. and if we add a negative sign, the negative sign will neutralize this one. It will be a neutral molecule, and this will be the base. Let's go to protonation of the hydroxide ion. If we protonate this, if we add a proton here, it will give us a molecule of water. This is, let's say this is the base, and we want to have a conjugate acid. We add a proton here. We add hydrogen and a plus sign. If we add a hydrogen here, it becomes H2, it becomes H2O. Then if we add a plus sign there, it neutralizes this one, and we have this. Conversely, if we want to have the base back again, you need to remove the hydrogen and add a negative sign. If we remove a hydrogen, we have OH, and we add a negative sign, it becomes an OH. So there are two ways you can protonate and you can deprotonate. You protonate to have a conjugate acid. If given a base, you can protonate to have the conjugate acid. If given an acid, you can deprotonate to have a conjugate base. The same thing with water. You can, let's say water is acting both as an acid and a base. If it's acting here like a base, now we can protonate it by adding a hydrogen here and a plus charge. If we add a hydrogen here and a plus charge, we will have this. This will not be the conjugate acid. On the other hand, we can deprotonate this to have the base by removing a hydrogen and adding a negative sign. If we remove the hydrogen, it becomes H2O. Then if we add a negative sign, it will neutralize this one, and we have this. That is how you can deprotonate. If given an acid, you can deprotonate. Given an acid, you are given an acid to have the conjugate base. For organic acid like this one, this is the conjugate base for this. This is the conjugate base for this. For a nitric acid, this is the conjugate base. This is the conjugate base. We are deprotonating. If we deprotonate this one, we have this. If we deprotonate this, we will have this. If you are given a negative here, C2H3O2, we can deprotonate it. We remove a hydrogen here and add a positive. We remove a hydrogen. If we remove a hydrogen here, it becomes this other one. So there are many ways we can do this in having an acid. Given a conjugate base and given a conjugate acid, to have the conjugate acid, if you are given a base to have the conjugate acid, you need to add a hydrogen and a plus sign. If you are given an acid to have the conjugate base, what you need to do is that you need to minus a hydrogen and add a negative sign there, and you have their conjugates. So you can, by doing like that, we now know what are the conjugate acids and bases of the corresponding acid and bases. So by doing like that, you can do as many examples as you can, and you can determine the conjugate acid of a base. Once more, we said every acid has a conjugate base and every base has a conjugate acid. And by removing a proton, we give a conjugate acid. And by adding a proton, we have a conjugate base. So acids are proton donors, according to Brønsted Lowry theory. Meanwhile, bases are proton acceptors. Then on Arrhenius law, acids are substances when they ionize in water, they produce hydrogen ion. Then bases are substances when they ionize in water, they produce an OH or a hydroxide ion. So these are the two theories. They differ in one way or the other, but they mean one and the same thing. Thank you very much. Bye-bye.